Good morning, students. Today we will be starting with Science 1, Chapter 6, Refraction of Light. In the beginning, there are some questions asked based on your last year 8 standard and 9 standards knowledge. The first question is, what is meant by reflection of light? Now we know that when light falls on an opaque object, they turn back. This is called as reflection. Now what is the meaning of the word opaque? Opaque means an object through which light cannot pass. What are the laws of reflection? Now laws of reflection are the angle of reflection is equal to the angle of incidence. The incident ray, the reflected ray and the normal lie in the same plane. The incident ray and the reflected ray are always on opposite sides of the normal. This is what we have learned in the previous classes. That was reflection of light. Now we will be learning something called as refraction of light. Now we have seen that generally light travels in a straight line. Because of this, if an opaque object lies on its path, a shadow of the object is formed. We have also learned in the previous classes how these shadows changes due to the change in the relative position of the source of light and the object. But light can bend under some special circumstances that we will be learning now. In reflection, when we were learning or when we learned about light, we said that light always travels in a straight line. We also said that the shadow, we learned about shadow, position of shadow, size of shadow, things based on the distance and the time of the day. But herein we will be learning a new concept called as refraction of light. Now to understand that, there are two experiments given over here. Let us understand the experiments given. The first experiment or the first activity is, take a transparent glass and fill it with water. Now take some portion of a pencil and put it vertically in water and observe the thickness of the portion in water. Now keep the pencil inclined to water surface and observe its thickness. That means you take a glass of water, fill it with half water, take a pencil and keep it perpendicular and see it through the water how it looks. Then you keep the pencil in a slanting position and now try to see. Now you'll be seeing in both the cases, that is point number 1 and 2, the portion of the pencil which is inside the water appears to be thicker than the portion which is above water. And in the second case, the pencil appears to be broken near the surface of the water. Means when it is perpendicular, it looks, the portion part which is inside the water looks thick as compared to the part which is outside. And when it is slanting, it not only looks thick, it also looks as if it is broken. Now why does this happen? Now this happens when we look in the portion of the pencil that is inside the water. The light travels from water to air through the glass. This light ray changes the medium and undergoes refraction. That means the ray of the light is passing from air to the glass to the water. As a result, the pencil inside the water appears to be thicker and broken near the surface of water. Look at the second activity. The second activity is, keep a 5 rupee coin in a metallic vessel. Take a small bowl or a vessel, keep a coin on it. Slowly go away from the vessel. Stop at the place when the coin disappears. That means you keep a maybe small bowl or small maybe plate or something like a glass or anything and keep the uh, coin inside, and you start moving behind till the point where you cannot see the coin anymore. Now keep looking at the direction of the coin. You ask somebody to slowly pour water in the vessel. You will be able to see the coin once the level of the water reaches a certain height. It looks as if the coin has come up. Now why does this happen? Now light rays coming from the coin emerges or comes out of the water and changes their direction due to the refraction of light. Because here also the ray of light is passing from different medium of water, that is liquid, to the vessel, that is solid, to air, which is gaseous. Thus the coin becomes visible once the level of water reaches a certain height. So from both this experiment, what we see is that light bends when it is traveling from one particular medium to another. That means from solid to liquid, liquid to gas, or gas to solid, from any medium when it is traveling. This in simple word is called as refraction. Now, if we are defining that, refraction is defined as light changes its direction when going from one transparent medium to another transparent medium. This is called refraction of light. This is an experiment to prove the refraction of light. What you do in this case is, you take a blank paper and you keep a glass slab on it and draw the outline PQRS as shown in the diagram. Draw an inclined straight line on the side of PQ so that intersects PQ at N. So what you do is, you draw a perpendicular line and then you draw a line over there, inclined line, so which is meeting at N. Pierce two pins vertically at point A and B. Means you draw a angle, small angle of incidence, and maybe 45 degree or 60 degree or 30 degree, and you put two pins over there. Now again put back the glass slab and go to the other side and try to see in such a manner that the image of A and B are in line with C and D. Again put two pins at C and D. Now remove the chip and the pins and draw a straight line passing through points C and D so that it intersects at S and R at M. Join the points M and N and observe the incident ray AN and emergent ray MD. So to explain to you again, you take a blank paper, keep a glass slab and draw a outline PQRS. Then remove that glass slab and draw a perpendicular line. From that perpendicular line N, or the point N, draw an angle, small angle of incidence, and put back the glass slab and put two pins A and B. Now try to go to the other side and put two pins C and D in such a manner that when you observe them through the glass slab, they appear to be in a straight line. Then take out the glass slab. You will be seeing it is not in a straight line. So draw the straight line, that is AB, as a dotted line, and join all the points, that is AB, and then from N to M and from M to D. Now herein AB is called as the incident ray, MD is called as the emergent ray, and then NM is called as the refracted ray, or the line that is getting refracted. Angle I is called as angle of incidence. Small angle R is called as the angle of refraction. I1 is called as second angle of incidence, and E is called as the angle of emergent. Now the first, if you see over here, there are two times light is bending. When it is going from air to glass slab, at point N, the AB ray or the ray of light is bending. Again it is bending the second time at point M when it is passing from the glass to the air. Means when it is changing the medium from the gaseous to the solid at point N, there is a refraction happening. Again at point M, when it is changing its direction from, when it is passing from solid to air or gas, it is again getting refracted. So the first refraction occurs when light ray enters the glass from air at N on the side PQ. The second refraction occurs when the light enters air through glass at point M on the side SR. For the first refraction, the angle of incidence is I, while for the second it is I dash or I1. The angle of refraction at N is small r. You have to see over here that angle I, that is I dash, is equal to R. In the second refraction, the angle of refraction E, which is equal to I. This is different from what we have learned in reflection. Here the angle of incidence is not equal to angle of refraction. Here the original angle of incidence is equal to the angle of emergence. Now, if on the both parallel sides PQ and RS of the glass slab, the change in direction of light ray is equal but in the opposite direction. Thus, the light ray MD emerges from the glass slab is parallel to the incident ray AN on the side PQ of the glass slab. But the emergent ray somewhat displaces. That means, suppose there was no glass slab. So, how the line would have traveled? The ray of light would have traveled as A, B, N and going towards the dotted line. But now, because of the refraction or because of the glass slab, it has got refracted. A to B, then it is N to M, and then M to D. Now there is a small question asked over there. Will light travel through a glass slab with the same velocity as it travels in air? No. The speed of light is different in glass as compared to air. Means the speed of light changes from medium to medium, solid, liquid and gas. Second question is, will the velocity of light be same in all the medium? No. As I told you, the velocity of the light will be different in different medium.